This is my presentation on absolute value and inequalities. Rick is on a road trip in Canada and he wants to figure out if he is speeding. Inconveniently, speed is measured in kilometers per hour in Canada. If he goes 15 kilometers per hour over or under the speed limit, he will get a ticket. However, because Rick is from America, he has miles per hour on his speedometer and needs to convert kilometers per hour to miles per hour. So first, we're going to write an absolute value inequality showing speeds that are okay if the speed limit is 100 kilometers per hour. Step 2, convert kilometers per hour to miles per hour if there is 1.61 kilometers in a mile. Step 3, solve the absolute value inequality to find the acceptable speeds in miles per hour. Step 4, graph acceptable speeds on a number line to show acceptable speeds graphically. So first, we have to write the absolute value inequality. This one shows that we have to stay within 15 kilometers per hour of the speed limit, which is 100 kilometers per hour. We convert kilometers per hour to miles per hour by multiplying by miles per 1.61 kilometers. If you notice, kilometers on top and bottom cancel out when we multiply. This leaves us with miles and hours. We do that with this number and this number. So we're going to plug those new numbers back into the equation. And then we are going to rewrite our absolute value inequality using this rule. So x has to be larger than y, or x is going to be smaller than negative y. On the negative inequality, the sign is flipped. So we have s minus 62.11 is smaller than 9.32, or s minus 62.11 is larger than negative 9.32. On the inequality with a negative, the sign is flipped. So we isolate s by adding 62.11 to both sides, and we need to stay under 61.43 miles per hour or over 52.79 miles per hour. To graph it, we have to put open circles at the endpoints to show that those aren't included, but the numbers between those two endpoints can be included, so we make that bold. To sum it up, we wrote an absolute value inequality where the distance from 100 kilometers per hour was smaller than 15 kilometers per hour. We used dimensional analysis to convert kilometers per hour to miles per hour by multiplying by miles per 1.61 kilometers to cancel out kilometers on top and bottom. We use the inequality rule to rewrite the absolute value inequality as two inequalities, making sure to flip the sign on the inequality with a negative. We isolated s by adding 62.11 to both sides of both inequalities to get the fastest and slowest you can go. To graph the resulting inequality, we put an open circle at the endpoints to show that they aren't included, and make the line between the points bold to show that those speeds are acceptable. So if you're in Canada or anywhere that isn't America and don't want a speeding ticket, do this. Check your speedometer. Let's say you're going 60 miles per hour. Let's say the speed limit is 100 kilometers per hour. Just quickly tell your phone to multiply your speed by 1.61. This is basically performing the dimensional analysis. If you notice, the miles on top and bottom cancel out to get you kilometers over hours. In this case, 60 times 1.61 equals 96.6 kilometers per hour. So we're going to add 15 kilometers per hour to the speed limit to take into account the speed buffer. Compare your speed to the speed limit, and 96.6 kilometers per hour is less than 115 kilometers per hour. So in this instance, you're not speeding.